Hi everyone, we'll wait for others to join. So I guess everyone is here, so we can start. So first of all, I would like to thank you all for coming. It was like really good journey with all of you guys. Not only you did really well with your projects, but with your questions and your doubts, we also got to learn new things, and it was really exciting for all of us. And looking forward for everyone to display their projects and see how it goes. So I want to wish all of you guys a very best of luck, and don't get nervous. Just take your time, and things are gonna go great. Jared, do you want to add something to it?
Nope. All I have to say is that I know y'all are going to do great, and good luck with your presentations.
Okay, so let's start. So the first student that I'm gonna call upon is Sundeep. Sundeep is a student with great coding skills, I would say. Not only he's an active listener, but he also actively participates in the class. And along with that, he has strong thinking skills and adding modifications. So he's a great learner, I would say, and likes to get in-depth knowledge of every aspect and loves to ask questions. So yeah, Sandeep, your turn now. Best of luck. Do well.
All right, hi everyone. My name is Sundeep, and I'm a rising 12th grader in Dublin High School. Prior to beginning this program, I have had experience with programming, but I want to explore more in mechanical and electrical engineering, so I decided to attend Bluestem summer program. For the project this summer, I decided to take on the task of building the mobile controlled robotic arm. The robotic arm has a claw that can pick up small items and move it to a certain spot. Here's a quick demo of how it works. Using MIT App Inventor, I created this app interface to be able to control the robot. And with the app, I can make the robot move forward and backward, right and left, and the claw can open and close. Additionally, I also added a modification such as the PS2 controller, which I can show after I upload the code. This is control. This is the controller looks like, and it does the same thing as the app, but
Sundeep, I think you're muted.
my bad. So the main goal of the project was to be able to control the robot arm using a mobile device. And at first, the project seemed overwhelming, but once I took it step by step, it became manageable. I first started with learning the basic functions of the parts such as servos and Arduino boards. Then I started to work on the physical component of the robot itself. Lastly, I connected the HDFI Bluetooth module to a cellular device for wireless compatibility. Once all that was successfully completed, I was interested to further add modifications to the project. I ended up adding a PS2 joystick sensor controller to the robot arm, so instead of using a mobile device, you can use the joysticks to control the robot. One challenging part of the entire process was coding the mobile app and connecting it to the HDFI Bluetooth module. I managed to solve this by looking at multiple YouTube tutorials and websites to find a suitable solution. I chose this project because the robot arm was very interesting, and I've seen it in many factories and companies. I was curious to learn how it functions, and being able to use the robot for personal use was very appealing. Throughout the program, I picked up essential skills that that will help me when I get a career in the future. With this project, I have learned that by taking your time and not rushing things is very important, and that was what helped me be successful in this project. I learned about different electrical parts and got introduced to programming with C++ for the Arduino IDE application. With the knowledge that I've gained during this 3-week program, I hope to apply it in the future and build more projects. Bluestamp helped me explore a brand new field of engineering, which provided me with the skills for the future. Thank you. Do you have any questions?
All right. Awesome presentation, Sundeep.
Yeah.
I was actually wondering, you uploaded a different set of code for the first demo versus the second. What is was there a particular reason that you used two different sets of code? Like, does stuff interfere?
Yeah, so the first one is for the mobile app, and I can't use same code for both of them, so I have to make a new save file for the controller itself. And yeah, I had to run both separately because I can't do it at the same time.
Nice, makes sense. Do you have any challenges with the hardware specifically? Yeah,
so actually when building the robot itself, some of the parts like broke because I put too much force back in, but fortunately I can replace them. So from now on, I'll be more careful with the parts so I won't break them.
I actually have, I got that same robot arm kit after, I think it was after you had a little trouble with it. And I also broke parts on it.
Yeah.
So half of it's held together with super glue right now.
Yeah.
Very cool.
Yeah, it was a great presentation, Sundeep. And keep up the good work. Best of luck.
Yeah, thank you.
So the next student we have now is Samuel. As you all can see, he's always smiling, a smart kid with a smiling face and never giving up attitude, I would say, no matter how things go wrong. But he will always show up in the office hours, ask questions, and try to get his things done. So that's a really good skill, I would say. And along with that, he's really good at assembling parts, mechanical stuff. So yes, looking forward for your presentation, Samuel. Go ahead. Best of luck.
Hi, my name is Samuel, and I go to Norcliffe High School. I'm a rising senior, and I also chose the Arduino robot arm because I love assembling things. But prior to Bluestamp, I have no prior like coding skills. So during this time here, I learned a lot about coding, which was really awesome. So right now I have one set of code uploaded right now, which was the PS2 controller. I also did, I also did the app as well, but I don't have the code uploaded right now. So right now, all I have is this code for the Arduino PS2. One challenge that throughout this project was coding, because since I only have no prior knowledge of it. So that was a great help for me coming here. Also, I am very good at assembling things. This was pretty easy to assemble for myself. I might have broken like 1 or 2 parts here because I was so excited to build it. So also, it was really exciting. I always go to office hours. It was really fun meeting new students and new friends, new teachers and instructors here.
That was great, Samuel. Does anyone have a question that they would like to ask him? Okay, I have a question, Samuel. Now, how comfortable are you with coding? Do you think you want to go ahead in future with coding?
No, I wouldn't say I'm very good at it, but I would say that I'm like halfway there. Like I learned from with no experience, think I learned pretty much most of difficult coding.
Yes, you did great, and best of luck for future. It was really good. Thank you, Samuel. Jared, do you want to go next?
One of my favorite quotes that I thought of when you meant both of you mentioned breaking things is I got a shirt. Oh, God, I don't know where it was from. I think it might have been from MIT that said engineering is the art of taking things apart and then fixing them. So you have to break stuff before you'll ever be able to really learn how it works. So breaking things as you build it is one of the most useful learning experiences that you can have. I misquoted it. The shirt said, if it isn't broken, take it apart and fix it. That's what it was. My favorite shirt. All right, next up, Sohith. So Sohith, you were an excellent learner all the way throughout here. And you always did a really good job of listening closely, and you asked good questions when you reached a point where you were stuck on something. You had to work through a lot of technical issues trying to do the machine learning on the Raspberry Pi, which ended up being way harder than we had expected it to be. But even so, you still managed to keep a positive attitude throughout everything, even when we kind of had to backtrack away from some stuff that we put a fair bit of effort into. But that's all part of the process. So with that said, go ahead and share.
Can I share my screen for the slides?
Yes, it should be turned on.
Let me see. Is that working?
Yes, it is.
All right. All right. My name is Sohith. I'm a rising sophomore at Cal High in San Ramon, California. And for my project, I did object detection with deep learning on Raspberry Pi. I chose the project because I felt like Raspberry Pi, or I feel like deep learning and machine learning are going to be like the future. And I thought it would be a good idea to get a head start now. And before this, I only had like the very basics of Python. And I did know a lot about computer parts because I built the PC and I've done a lot of research in it. So that helped with the Raspberry Pi a lot. Just a brief description is I used the project to basically teach a machine to identify what airline a certain plane belongs to. With the program that I created, I can basically upload an image or of an object into a folder, and then the code will basically run and let us know exactly what we're seeking. Technical components that were used were Raspberry Pi, NanoNets, and then Docker and Nginx. The Raspberry Pi was basically used to host the web server that was needed, and it was also the user interface. NanoNets was the API, so it worked like the cloud, and it basically helped us train our model. And Docker was used to like house the whole program, and it basically helped us with one of the crucial steps later on. So one obstacle that we ran into early on was in order to get the project going, we had to train our own model, and it didn't quite work out how we wanted it to with TensorFlow and transfer learning. So instead we ended up using NanoNets, which is the API. Another obstacle is NanoNets only lets you use it 1,000 times a month, which seems like a lot, but it runs out pretty fast after testing. So in order to kind of combat this, we made a code that lets us run the API multiple times for the testing pipeline. So then once we're finished with that, we'll still have a lot of uses. And last obstacle is when using the API, it made us input a link of the image. So instead instead of that tedious process, we basically created a server, a web server, which is where Docker comes in. And that lets us put an image directly into a folder, and the code and program will do all the work for us instead of getting the link ourselves. Here's a quick demo. Oh, for the audio, I meant to share the audio, but basically I was saying that you could put any image into this folder, like I said before, and then this code will basically turn that image into a link on the web server that we created, and that'll go directly to this code, and basically run it to give us results like this down here. And it tells us what airline and how certain it is. And then, yeah, that's pretty much the demo. And yeah, so I joined BSE because I thought it would really help me kind of kickstart my future in the engineering, which is something I really love. And I picked up a lot of new skills, and I further enhanced the ones I already had through this program. And in the future, I could utilize this project not only with the code and software I got out of it, but the skills I learned for example, a security camera of like with the machine learning, figuring out what's different from one picture to another, or I can use it for the same exact like object detection of like planes or adding more airlines or yeah. So that's my project. Hope you guys enjoyed. Yeah.
Good job, Sohith. Thank you.
It was really great. And there's so much to learn from this, I would say this.
Not pictured in the presentation is all of the time we spent trying to figure out how to make the machine learning model all on our own before we ended up getting onto NanoNets.
Yeah.
So I think we spent almost a week trying to do that and didn't end up using it. But we learned a lot about it on the way. So very good job.
Yeah. Does anyone have a question? Okay. So let's go to the next student. So we have Atri, who is not only hardworking, consistent, and I would say he has great problem solving and debugging skills, but he is always willing to learn, and he's always willing to put efforts. If something is not working, he will show up in the office hours, is always there and trying to do something or the other. That's like the best part. And I would say like not only he did the project, but he started with the modifications. He thought like, okay, what extra I can put and what extra I can do in this to increase my skills. So that is one of the best skill that anyone can have. So I wish you best of luck, Atri. You got this.
Hi everyone, I'm Atri and I'm a rising junior at Lequan High School. So the project that I chose was the phone controller arm, and I chose this project because I wanted to explore mechanical engineering a bit more, as well as have a chance to do some coding. I also have some prior experience with basic Arduino programming and Python, and I've done some engineering courses at school. So in the end, I was able to effectively assemble a robot as well as program it, and I used the HC05 Bluetooth module in my mobile device to wirelessly control it. And I can demonstrate with what my arm looks like. So this is my arm. And using a software called MIT App Inventor, I designed an app to connect to the robot. So here there's like a scan button to check for Bluetooth devices and then a way to connect. And then there's a variety of different control you can do. So first I'd scan and then connect to the robot, and then I can just click and I can move it left and right. I can also like move it forward and backward. There's a variety of different things I can do with Bluetooth. And then I also did a PS2 controller modification. This is what it looks like, just a little PS2 controller. And I have to actually upload a sketch file for it. So give me a second. Okay, so it's kind of similar to my Bluetooth app, except it's like a physical version. So I can just move the joystick back and forth and like rotate and move up and down. And I can open and close the claws. So yeah, that was another modification I did. So for my project, the first week, I just started with programming, servo motor, and getting my Arduino working. I just also worked with wiring connections through a breadboard and interpreting wire diagrams. And then the second week, I assembled my robot, as well as finished wiring it with my 4 servos, which serve as the joints of my robot, as well as using my Bluetooth module. I did add an extra modification, which was the potentiometer modification. This is like a little knob that you can like turn back and forth. And I wrote a program for it, which would allow me to like read the position of it and then put that the position of my servos. And then the last portion of my project was just spent working with the HCF5 Bluetooth module and connecting my Arduino to it, as well as with the PS2 external joystick sensors. And also with the joystick sensors, I did have to install a library for communication, which was designed specifically for the PS2 controller, and connected it to the analog pins on my board to control the robot. So throughout my project overall, I worked a lot with servo motors as well as with the Arduino IDE. I also in general just gained much more experience and knowledge with coding with Arduino, specifically in like languages similar to C and C++. And I didn't really have much experience with applying my coding skills to an actual project. So this really gave me a lot of experience in that sense. And then I ran into a lot of challenges. I guess a big part of it was with assembling the robot itself, because there's a lot of different lengths of screws and parts, and some things I messed up the placements with, so I had to reassemble some things. And also just getting the Bluetooth and PS2 controller working. There's a lot of different like little bugs in my code as well as with wiring, so there's a lot of things I had to troubleshoot there. And for my project overall, I guess it taught me that just to be more precise and attentive to detail, because there's a lot of different things that can go wrong. And just one small mistake can cause everything to stop working. And I also improved my troubleshooting skills because there's a lot of different challenges I had to overcome. So that was really helpful. And so overall, attending a Bootcamp has really helped me to develop my engineering skills, and giving me a unique opportunity, as well as that there's many things I've learned here that I'll definitely take in the future endeavors. Thank you. Any questions?
It was great, Atri. Congratulations. So I have a question for you if no one is asking. So what do you think? Like, do you think mechanical part is easy or the coding part, since you're familiar with both now?
I think for me, the mechanical part and the assembly felt like I kind of knew, I had more of a clue as to like what I was doing, what steps I had to take. It was really hard to assemble, but I think I'd say both were actually equally hard, but the assembly, I guess, took maybe a bit less time.
Okay, that makes sense. Thank you so much, Atri. And next we have is Darshan. Would you like to introduce him, Jarrod?
Yes, I would. Let me grab my thing again. All right. So next up, we've got Darshan. So Darshan, you were very confident and independent. You ended up solving a lot of your problems before we even got back around to figuring them out. And you integrated a lot of modifications on top of that base project that we started out working with, which is excellent. And you also ended up using multiple programming languages. So we didn't even end up sticking to just Python. You did a little bit of work in JavaScript as well, which was very cool. So you got a lot going on in your project. So if you would go ahead and share your screen and tell us about it.
Yeah, sure.
And I don't remember if your video has audio, but if it does, when you share screen, make sure to check the share desktop audio as well.
I can just, I actually wanted to unmute and explain it myself.
Okay.
Yeah. Okay, so hello, my name is Darshan Dewadi, and I'm a rising senior at Imdor Valley High School. And this is my demo night presentation. So just to introduce, my base project was supposed to be using a Raspberry Pi camera to capture an image and use a machine learning model to identify the object. So this is the Raspberry Pi and this is the camera. I picked this project because I was interested in machine learning and coding. Despite not knowing much about machine learning, I chose this project because it would allow me to learn and pursue my passions. Coming to this project, I didn't know how to code in Python or Java. I did know how to code in Python or in Java, and it helped me a ton throughout this project. However, I didn't know HTML, Java, and CSS, and I had to learn it in order to build one of the functionalities for my project. So this is my project description. It consists of two components. The left side is coded in Python and did much of the heavy lifting in terms of the process of capturing the image, processing the image, QR code. The QR code, when scanned with an iPhone, gives you a Wikipedia link to the object. And the right side is an HTML website I created, and primarily users will interact with that. And it also has a button when pushed after the image is processed, reveals the possible object in the image as well as the QR code. So this is the image. I hope this loads in. Let me just mute this. Okay, so this is the website, and this is the button I was talking about, which you can press and it reveals the object as well as the QR code. And basically how you go about this is that you have to cover the camera and then release it, and it starts a countdown where you can capture the image. So yeah, it's just me starting the program. And this image is actually a set of images that shows the live video that the Raspberry Pi camera sees. Although it is a bit slow since it has to do a lot of processing and stuff. And right about now, I should be, yeah, see, it's freezing up, meaning that I covered the camera at this point and I released it, and it's going to release its final image right about now. Yeah, there we go. This is the final image that the Raspberry Pi captured, and I'll be pressing the button to see what object it is. And now it's saying that it's a lampshade, and this is the QR code that leads you to the Wikipedia link. So next. Okay. So one major obstacle in this process was the connection issues. So basically, my Raspberry Pi was having difficulties connecting to my Wi-Fi network, and that caused me to not be able to code further and halted my progress. And I was able to overcome this by directly connecting the router to my Raspberry Pi through an Ethernet cable. And this leads to my general lesson learned, which is that whenever things aren't working, don't give up trying to solve it. So to achieve this project, I had to do multiple things and achieve a lot of goals, such as the video, live video, and the HTML website. Initially, they weren't really working out. However, I didn't stop researching it, brainstorming solutions, and eventually I was able to make it work. So that concludes our presentation. Thank you. Any questions?
All right, thank you, Darshan. Excellent presentation.
It was
So
very informative.
yeah, when you give it a picture of something that's like a white background, it makes sense that it might try and think it's something weird, but what are a couple of objects that we tried it on that it did actually work on?
Yeah, worked on a lot of stuff like a bottle, hat. I think it was a cup that was in my table, and it actually did work. Yeah.
Very nice. I think at some point you definitely need to show it a mirror and see if it recognizes that it's a Raspberry Pi. I think we should see if that works. Because if it does, I'm pretty sure that causes some kind of black hole. All right, excellent. So thank you for your presentation, Darshan. Next up, we have Alan. So Alan was very independent throughout this entire project, and you really did a good job of making the project your own, using your previous experience in comp sci. Wait, did he leave? No, he's still, okay. I was trying to find you in the blur of people and it wasn't popping up. You're on the second page, I see now. I got it. And you made a bunch of modifications to the original scope of your project and expanded it out to do a lot of work with the system theming itself and even working on one of the games on your system. So, well, that said, go ahead and show us your presentation. Let's see what you got.
Let me share my screen. So my name is Alan. I'm a rising senior at Homestead High School. And the project I chose was the video game emulator with Raspberry Pi, which you can see here. So my project is a RetroPie emulator, and it has some classic games and custom theming, as well as a custom ROM hack that I made. So here you can see my custom ROM hack. So what I did was I changed every character. So in battle, you'll see the guy here on the right was supposed to be a thief, but he's now a cavalier. And I also changed the name, portrait, and stats of every character too. Now, after I exit the game, you'll be able to see my custom theme, which is here. The default theme has a black background and the game data is below the thumbnail, but I changed that so it's on the right and below. And you'll also be able to see all the games that I have on this emulator. So a challenging aspect was trying to move things between my computer, where I coded the files, and the Raspberry Pi, where the files would run. So one solution I found was to upload the files onto a USB drive and plug that drive into the Raspberry Pi. Another solution was to push the files onto GitHub using my computer's terminal and pull the files using the RetroPie's terminal using git push and git pull. These solutions allowed me to run files I coded on my computer on the Raspberry Pi. All right, now the reason I joined Bluestamp Engineering and picked this project is because I am interested in software engineering, which this project covers, and video games are something I am familiar with. I have previously had experience working in programming languages, but something new I learned was how to use a terminal and work with files, and how to image an OS onto an SD card, both of which are skills that I can use in the future. So are there any questions about my project?
I was actually wondering, what programming had you done before you started here at Bluestamp?
I had taken like classes in Java and Python before, and I've also messed around a bit with JavaScript and HTML before.
Very cool.
That was really good, Alan. So next we have is Rahul. So I would like to say, especially for Rahul, he was one of the first student to complete his project. Not only he completed his project in one ways, he tried different ways to complete it. He did modifications. Really, I would say like he's a person who loves to explore new stuff, and with good coding skills and different and like with the enthusiasm to work, he really did well on with his project. So looking forward for your presentation, Rahul. Best of luck.
Thank you. Hello, my name is Rahul and I go to Dublin High School in Dublin, California, and I'm going to be an upcoming senior this fall. The project I chose is the Twitch bot. It is supposed to transfer the messages from the Twitch website onto the shell of the bot and run commands, which is part of my modifications for this project. I have some prior experience in Python, which is what this project is based on, and I use Twitch regularly, so I know the features of the app and what I can do to make the bot more efficient and user-friendly. I've also made a GitHub page to show my code and milestone videos. To show what the bot can do, you can type anything, such as !hello, after running. As you can see here, the bot, when I type exclamation mark hello, it returns hello and then my username. And then if I do exclamation mark random num, then it returns a random number between 1 through 10. For my Twitch bot, I first set up the Raspberry Pi and synced it up with my VNC code app, so I did not have to use my monitor to use the Raspberry Pi. Then I created the code from scratch using a guide, and I tried to debug the code and made my first milestone video. During the second week, I used the Twitch API to code their bots, and then I could make modifications to those. And I ended up making 2 modifications during that week, and then I made my second milestone video. During the third week, I cleaned my code, worked on the GitHub website, and made sure to debug some parts of the code that were not working. Quick rundown of my modifications. Using the Twitch IO, I made some commands such as exclamation mark hello, where the bot will spit out hello and the person's name in the Twitch chat. If someone types exclamation mark random num, then the bot will spit out a random number between 1 and 10. I realized that it was not working at first. To make the code work, I had to update the Python version from 3.9.2 to 3.10.5. But then the code was still not working, and I realized that I had to generate a new OAuth key to make the bot sync with my Twitch channel. I also made a routine function, which is down here, and it was to it shows a message of like and subscribe after every 10 seconds. In the future, I can add more modifications to display this automated messages to the users after a fixed interval of time. Some experiences I've gained from BSC are debugging skills, learning to use the Raspberry Pi, using apps such as VNC Viewer, Thani, VS Code, and learning about the Twitch API. I joined BSC because I wanted to use the Raspberry Pi for the first time and learn more about Python and APIs. I picked the Twitch bot as my project because I use Twitch a lot to watch my favorite gaming streamers, and I wanted to major in CS for college and have previous Python experience. Thank you for listening. You guys have any questions for me?
That was really good presentation, and I could see Jarrod's messages on the screen. So that was cool. You did a great work. You did great.
Thank you.
Rahul, so next I have Abigail. So for Abigail, I especially want to point out that she is self-directed, hardworking, independent, problem solver. Like she's ready to debug everything. With great coding skills, she has always put efforts to make her project like the best. Not only this, but she attended all the guest speaker lectures. That's like a big thing. Just after the class, she was always there, and even when she needed some help, she was there in the office hours. So she really put a lot of effort in her project, and looking forward for your presentation, Abigail. Best of luck.
Thank you. Hi, my name is Abigail. I'm a rising junior at Lindbergh High School, and I do have some prior experience in coding with Python and Java. So the project I chose to make was a MIDI controller, which transmits MIDI data to devices that can work with it. And I chose to make a MIDI controller because I work on rallies for school, and we have to make our own music or remixes for music that we dance to. So a MIDI controller would make that process a lot easier. Let me unblur my background so you can see this. So looking at my MIDI controller, I have these linear potentiometers that slide up and down. I have rotary potentiometers that are like knobs that turn, and I have these buttons. So all of them are connected to a breadboard and my Arduino, which are also inside the box, and my Arduino is connected to my computer. I spent most of week 2 trying to figure out like the software aspects, and it was pretty hard because most of the software I found was geared towards Windows. So I had to find a way to make my computer work with that. And it took a really long time, but I ended up finding software that was actually designed for my computer. So I ended up using the standard Fermata example on Arduino, and I also downloaded a connection kit on Ableton Live, which is the audio software I'm using, and that allows my Arduino to communicate with Ableton Live. I'm going to do a quick demo. So that's my box right there. The analog pins on my Arduino are connected to analog functions like the volume or the gain, and the digital ones are connected to, say, an instrument being on or off. So I just connected a button to the instrument being on or off, and if I go ahead and start what's playing, you can't hear anything. Once I press this button down, you should be able to hear that through my earbuds. I'm just gonna get rid of that mapping so I don't have to hold down the button the entire time, but I'm going to map one of the knobs to the gain and one of the sliders to the volume. So if I go ahead and start again with it just being on the entire time, and I move this slider, the volume goes down and it goes up again. I can't move it too far down because then you can't hear it. But that does adjust the volume. And then if I turn this knob, it changes the gain, which might be a bit hard to distinguish. But when the gain is higher, it sounds kind of bouncy. And when it's lower, it sounds more muffled. So that is my quick demo of how my MIDI controller works. And then about Bluestamp. So I wanted to join Bluestamp because I have worked with coding before, but I haven't really had the chance to work with tangible aspects of engineering like mechanical or electrical engineering. So during this camp, I've gotten the chance to learn a lot about Arduinos, and also I've worked quite a bit with like circuits, just drawing it because I took physics this past year. But I learned to translate those 2D diagrams onto my breadboard where they look pretty different. And I'm leaving Bluestamp with, of course, a MIDI controller that I can apply to making music, but also the knowledge that I gained over the past 3 weeks, which I can apply to future projects. Thank you for listening.
Great presentation,
Thank you.
Abigail.
Yeah, it was really great. And especially your project, it really shines out. So best of luck for your future. Thank you so much for your presentation. Jared, you want to go ahead?
I kind of wanted to know, you had like musical instruments set up to it right now. Have you tried it with any goofy sounds? Like just weird like radio presenter sounds? Because if you haven't,
Not
you definitely
yet,
need
no.
to.
I think I will try that after the camp, but right now I'm just using like a clip that's on loop.
Fair enough. All right. And then last but not least for live presentations today, we have Shreyans. So Shreyans, you were super enthusiastic. I think you might have ended up talking more than I did in some of the classes. And you did a great job. You've integrated both a Raspberry Pi and a Arduino system as part of your first segment here. And you found your own solutions to a lot of the problems we faced before I even got around to trying to help you with them, which was very good. And you've ended up with a project that is very much your own design, which is very cool. So with that said, go ahead and present your stuff.
Yeah, I'm just gonna share my screen for my presentation. And that is not. So hello everyone, my name is Shreyans Daga. I'm currently an incoming sophomore at Stanford High School. So for my project, I decided to make the ball tracking robot. And as a modification, I decided to also add gesture control to my robot. So the way my robot works is that it takes a picture through its camera, and then it processes that image and it'll try to find a particular color in that image. And it'll find the average value of that particular color, and then it'll tell the robot to move there. One of the biggest challenges was actually detecting and processing that image. And we ended up doing it 3 different ways, 2 of which were complete failures. So the first way was contour detection, where we pretty much just tried to detect blobs of color and then differentiate them from their environment. But this didn't work because of a very obvious reason, which is that there's a lot of blobs of color. So it was kind of hard to differentiate one blob from the rest, which meant that you were pretty much detecting everything. The second thing we tried was to perform contour detection using a Gaussian blur. which did improve the results significantly, but it wasn't good enough. And so finally, we decided to go ahead with HSV image masking. So pretty much the way that HSV image masking works is that you can take a picture of something and then convert it into an HSV file, which stands for hue saturated value. And this allows us to accurately filter out just one color. And as you can see in this image, I know there's really only one color, but it is capable of doing this for a wide range of colors. And so it'll just detect the red in the image. And then it'll, as you can see, it plots a little point where it thinks the average value of all the red pixels is in the image. And so here's just a quick demonstration on how my project works. So pretty much, once again, this is my robot. And so the thing that I'm pointing to right now is the accelerometer. And the second thing that I just pointed to is the Bluetooth module. They are connected to the Arduino through jumper wires. And so pretty much the way that it works is that the accelerometer is capable of detecting tilt, like I'm showing in the video. And so what it does is that as soon as it detects tilt, it sends that information over to the Arduino, which processes it. And it's like, hey, I'm detecting some tilt. And so it tells the Bluetooth module to send that information to the Raspberry Pi. And so as soon as the Raspberry Pi receives the information, it tells the motors, or rather tells the H-bridge to tell the motors to move in a particular configuration, depending on the gesture. So as you can see, the accelerometer, or rather the accelerometer on the breadboard is flat. And that tells my robot to go into ball detection mode, which means that it's going to try to take an image and find red in it. And so as you can see right now, I tilted it to the right and it starts spinning to the right. If I tilt it to the left, it starts spinning to the left. And so then if I tilt it forward, it goes forward. If I move, I know you couldn't see it there, but if you tilt it back, then it goes back. And so as soon as I set it flat on the ground again, it goes into ball detection mode. I just speed it up a little bit there. And so as you can see, it's trying to filter out red. This is my great red tower of bowls. And this is what I use for my image detection, simply because it's big. And so as you can see, the robot slowly moves towards the tower. I'm just going to speed it up a little bit. And as soon as it thinks that it's close enough, it immediately stops because it doesn't want to bump, which is great because we don't want to damage the hardware. So finally, my lessons and experiences that I'm taking away from Boostamp include the fact that I've gained a better understanding of how to work with the Raspberry Pi and setting them up, and how to work with an Arduino. I actually did have programming experience coming into the course, which was extremely helpful. I also learned about sensory input and actuator control. And the biggest thing I learned is probably troubleshooting. I used troubleshooting on literally every part about my project: the image detection, setting up the Arduino and Raspberry Pi, the Bluetooth, literally everything. And I learned and enjoyed the program a lot. Thank you for listening to my presentation, and I will now answer any questions that you may have.
That was really great, Shreyan. Especially you've used both like Arduino as well as Raspberry Pi. So it's just like two projects in one, I would say. Great job.
Now we have to figure out what the heck to do with you for the next couple of weeks. We were sitting in office hours on Wednesday, and you were talking about what you wanted to do. Some, I think your favorite idea, I don't know if it's going to be the right idea, but your favorite idea was we should now take a robot arm and put it on top of the autonomous car and then have it go actually pick up the ball, which we can try. It's a big ask, but we can give it a go. I'm willing. we gotta sell the rest of the people on it. So yeah, very good job. And I think that is the last of our live presentations here at the end. Before we finish up, I did want to give mention to the people who weren't able to come and present here today. So I think I had two. Jasleen, did you have any who weren't able to present? Okay.
No.
So two of my students actually weren't able to present today. One of them is in India, so it's about 3 a.m. right now for her. And the other one has a class that she's taking in addition to doing Blue Stamp over the summer that is going on right now. So she had to go to that. But I just wanted to give them a little bit of time here at the end. So the two that couldn't come is Lorelei, who did a fantastic job of going from very little previous experience with either hardware, software, or electrical engineering to build up a very similar robot to the autonomous car part of Shreyans project that we actually just got working last week after a couple of frustrating issues with her hardware, but she managed to persist through that, and I was really proud of her for doing that. And then the other person who is not able to be here today is Shiny, who did a similar base project, but different end application to Sohith's, which was taking the machine learning on the Raspberry Pi project and switching it up entirely using an entirely different software library to do facial recognition on the Raspberry Pi. So she ended up with a system that she could run that would take pictures of known people's faces, take a picture on the Raspberry Pi camera, and output to tell you, yes, this is the person, or no, this isn't the person. And she managed to get all that